In this video, you will be presented with an overview of a .NET Azure App Service Diagnose and Solve Problems Generated .NET Trace report, which was captured to diagnose a high CPU issue. Additionally, the manual analysis of the same trace using PerView on your local machine is included. It is expected that you have already downloaded the .NET Profiler Trace and PerView. A link to the video showing how to capture this .NET Profiler trace is provided in the description below, as is a link to the official PerView download GitHub repository. Select the web link icon next to the instance name to open the .NET Profiler trace. Notice the breakdown of time spent in request execution between application code, platform, and network. Notice the list of slowest requests. Navigate through the different tabs and analyze the findings. For example, slow requests, failed requests, thread call stacks, .NET Core exceptions, and CPU stacks. For this specific scenario, take a look at the Thread Call Stacks tab. You'll see a stack with the non-Microsoft assembly. On that stack, you see the system.text.regularExpressions method, which is a clue. As we know, poorly written regular expressions can cause high CPU scenarios. Look at the CPU Stacks tab. Click on the Stack button. You can see specifically what is going on. In the module named C#guitar.dll, there is a page named High CPU Hang, which appears to be the culprit and is utilizing a regular expression. Provide this input to the party owning this assembly and have them investigate the code. To analyze the .NET Profiler trace locally, open the .diag session file in PerView. Double-click the diag session file. It will take a few moments to load, so please be patient. Once loaded, double-click or expand the .diag session file to expose the ETL file. Double-click the ETL file. Double-click CPU Stacks. Notice that the .NET process has the highest CPU MSEC value. Therefore, it has the highest amount of interest. You can also see the command line includes a non-Microsoft assembly, which is also an important point of interest. Double-click the .NET process. Select the Call Tree tab. Notice that the threads are ordered by INC%, which identifies how much resource is being consumed by this thread. Check the checkbox next to the thread with the highest INC%. Navigate into the thread check by check until you reach the non-Microsoft assembly. Provide this input to the party owning this assembly and have them investigate the code. And finally, but extremely important, is to recognize that memory dumps and .NET traces contain very sensitive information. Take extreme precautions and follow documented procedures for handling of these files. Remove them from all devices once they are no longer needed.